Hey guys, this is the demonstration video that goes along with Explore 2 for Geoscience Processes. It's called Larger, Small, Faster, Slow. Um, if you might recall from the last Explore, we talked a lot about the amount of land area that is affected by a geoscience process like an earthquake or a landslide or weather. In this case, we're going to be talking more about how fast things happen or how just what sequence things have to happen in time. Okay, so this is a fairly easy one to do at home as well. So if you want to try it out, talk to the adults in your house and see if it's possible to get together just some frosting and some graham crackers. Pretty straightforward. So what we need here, I'm going to take two of these graham crackers that I've already broken up. And this frosting is on a piece of parchment paper. We've tinted it red so it looks more like magma because the whole idea is that this is the mantle, which hopefully then you know what this would be if it's sitting on top of the mantle, because that's one of the questions that you have to answer. So I'm going to put these two graham crackers on here and notice that, because they're on because frosting is what it is, it's pretty fluid, so I can move this back and forth. All right, so what I'm going to do is I'm going to put these two together because they were originally together, sort of. And I'm going to demonstrate what happens at a fault line. We talked about these boundaries a lot in the last chapter, if you recall. This is all going back to all the things we talked about in second quarter. And you might recall that we said that sometimes the plates will pull apart, which is what we saw at the Mid-Atlantic Ridge, right? And then the magma would come up in between and would form new crust and so on and so on. It's also, we also talked about places where like an ocean crust would subduct underneath a continental crust. This time we are going to talk about a transform fault. So we're going to have these two things. Now they're pretty close together here, but they're going to move in opposite directions. So what's going to happen here, if you recall, if I just do this with my fingers, I could put a lot of force behind it, but I'm going to try to do this kind of slow. Okay, now I don't know if you noticed, but there's a little bit of crust that flaked off there. Okay, so as these two are moving past each other, the surfaces that are facing each other are rough, and so they're catching on each other. And as a result, I have to put a little bit of force, and then it'll sort of jerk until it moves forward. Okay, so if you look at your questions for this section, there are 6. The first one wants to know, what part of the earth did the graham crackers represent? Okay, so remember, we have magma down here. That's supposed to be the mantle. What is it that lies on top of the mantle? If you're not sure, go look up the inside of the earth, the structure of the earth, and find out what the outer part is called. What type of geological event does this model illustrate? Remember, when this actually moves past each other and it shudders up against it, we have everybody that's living there is going to go through a lot of shaking. Okay. And then, does this geoscience process happen on a large scale or a small scale? Okay, is this a big event or is it one that's really small, one that you wouldn't necessarily notice if you weren't watching it happen? And then, how fast does it happen? Okay, when earthquakes or landslides or these kinds of things happen, do they happen very quickly or do they take a long time? Right, and then finally, it's going to ask you to think of some places where this happens in the world. If you need to go back to our plate tectonics map, that might be a good place to check, like especially around the Ring of Fire. But, I'm sure some of us, we've talked about them enough now that you probably have some ideas where this kind of event can happen. All right, so I'm going to ask you to pause the video here. And I'm also going to pause and reset a little bit so that I can show you part 2. So go ahead and pause, and I'll be right back. Okay, so hopefully at this point you have finished all the questions for part 1, and you're ready to observe part 2. In part 2, it's much the same. As you notice, I've smoothed out my mantle of frosting here, and I have a couple more graham crackers. I also now have a cup of water with me. So what I'm going to do for this one, and this again will be familiar, I hope, because we talked about this kind of thing a lot in chapter 2. So last quarter, when we talked about how those tectonic plates move relative to each other, if you might recall, we talked about what happens if there are times when they move apart, times when they move together, and times when they move past each other. Typically, when we talked about convergent boundaries, where plates are moving into each other, we really focused heavily on how those plates behave when one is an ocean plate and one is a continent plate. In this case, though, we're looking at 2 continental plates. Okay, so we have 2 continental plates. And we did talk about this too, but this is the first time we're really talking about it as a process. So what I'm going to do with each of these, just to make this illustration a little clearer, is I'm going to dip just the edge of each of those in some water. I'm going to put them back on our mantle. And again, I want you to envision that these are two continents that are running into each other. Okay, and there was one really key part of the world that we talked about where that's happening and is continuing to happen. But anyway, so now we're going to show what happens when we push them together. So I'm just going to push them together. And this probably won't be a big surprise, but look at that. We have formed a ridge. Now, this is not how the Mid-Atlantic Ridge forms. Okay, Mid-Atlantic Ridge forms when these things are pulling apart and they're forming mountains coming up from in between. But in this case, they're pushing into each other, and boom, we have a ridge there that forms of another type. Okay, so what part of the Earth did the graham crackers represent? This has not changed from the last time, so your answer to this one should be the same as the last one. What type of geological event does this model illustrate? Okay, so we're building something here. When you have a big, ridge of land like that, what did we build? Right? We've talked about that process a couple of times in the slides before now, so hopefully that's easy for you to figure out. What motion does it model? Okay, so is this a transform plate? Is this a divergent plate? Is it a convergent plate? What's happening there? And then, does the geoscience process happen on a large scale or a small scale? Is this something that causes just really small changes, or is this a really big change? Now, by the same token, does it happen very quickly or does it happen very slowly? Okay, that's the question for number 5. Now, I want you to think about this. And again, this is where you need to think back to when we looked at plate tectonics and how the different continents moved around each other from after Pangea. If you might recall, in particular, the India plate, remember, moved northward and crashed right into the Eurasian plate. And then we saw this happening. Okay, so it started to happen way back in prehistory, and we know that it's still happening now. So think about that in terms of how fast it's happening. And then finally, you want to name some places where this is happening in the world. So I just gave you a really big clue for that one. But there's other places too, and it wouldn't be a terrible idea to go look up places where the mountains are still growing. Okay. All right. That's all for this one. If you have any questions about it or need any help with it, please don't hesitate to email me. Thanks. Bye.